Hey everyone, let's break tradition today on Workshop Quick Takes and try doing a Workshop Quick Take. As a member of the YouTube community, I like to think that I have fans. Here's one of them. This particular fan has an issue though. When I turn it on, it takes a minute to come on, and that's on 3, and it's not moving much more air than other box fans I've got due on like 2. Now, it is a little out of balance. You can see it shaking there, so maybe that's part of the problem. But there's another issue that I want to try and tackle. Let's pop the cover off the back of this fan and see what's in here with the motor. Okay, now that we've got that off, we see that there's more going on here than just this motor. There's also this capacitor. Now my understanding is that means this is a capacitor start and run motor. Now if you think of large induction motors, a lot of times they'll have a mechanism where they use a capacitor on a starter winding to create a phase shift and then pull that capacitor off using a centripetally accelerated switch which flies open and disconnects that from the circuit. And the reason being for that is the capacitor, while giving you the necessary phase shift on your starter winding to get things turning, it also limits your peak torque. So if you kick it back out of the circuit once you're actually rotating in the right direction, then just running as a straight induction motor gives you higher torque. But for a relatively small motor like this, you don't need that much torque. Problem with capacitors, even these solid state types like this one, I think this here is a polyester film dielectric, is they do get eaten away over time. So it is possible that if this capacitor is not fully up to spec, so capacitors come in a lot of shapes and sizes. Here's kind of an extreme case. 10,000 microfarads at 63 volts, and you see how big that is in my hand. So that there, pretty hefty. And this is an aluminum electrolytic. It uses a wet electrolyte compound, and it is polarized. Note the negative pointing one direction only. If you put reverse polarity on one of these, it will swell up and possibly explode. Here's something that's 16 volt, 100 microfarad. Unfortunately, certain types of electrolytes, not just aluminum electrolytics either, but also tantalum, which is a type of solid dielectric, has a relatively large amount of capacitance compared to its physical size, but again, you do run into the issue that they are polarized. And in fact, a tantalum, if you plug it in backwards, it can actually catch fire just like that. These mylar and polyester types, which are two common solid dielectrics using plastic films as the separator media, they come commonly in these rectangular plastic containers that are potted. Here's one, however, that's a 0.47 microfarad at 250 volt. Here is 0.22 microfarad at, what is that, 250 volt. So these are fine for line filters, but notice how large that is relative to the amount of capacitance you're getting out of it. So, yeah, there's a price to be paid for having a solid dielectric that is bipolar. But in any case, what that's getting us around to is we have here a capacitor that is, let's look at that closer, upside down. But it says 6 microfarads, plus or minus 10%. At 250 volts AC. This is a common size not only in box fans, but I understand it's also used in some older ceiling fans, and so you can buy replacements pretty readily. 6 microfarads, 450 volts. The voltage is over-spec'd, but it won't affect our energy storage at the rating we need here, so I'm wondering if we swap this capacitor into here, will we get an improvement? Only one way to find out, so let's do it. Do I want to pull this fan motor all the way out in order to make a clean connection back in here? The answer is, I do not. And they've anticipated that by providing this little crimp terminal connector. It's not quite like a Wago, it's something cheaper than that, and something I don't really trust either. I'm going to try and use something a little better than that. This is called a power plug. It's meant for going up into like can light fixtures and things of that nature. It has these nice little push-in one-way connectors. Again, fully unplugged. Let's just go ahead and snip this off here. And there. See how much wire length we can get on there. Actually, I have the right tool for this. I should use the right tool for this. There. Insulation stripped, no damage to the conductor. Just the way it should be. Now, by convention, whatever side has the sockets the least exposed is generally where you want to put your source, and the other one is for your load. So since the power will actually be live on these two pins and then the capacitor will just plug into it, I'm going to use this one on this side. That is clearly not the right connection for this. In that case, we're going to switch to the next best thing. Let's try and set a couple of these 3-port connectors. So you know what we might be doing? We might actually be soldering this. Set the old soldering iron off to the side here. We can go ahead and prep this one also. It looks like it's pre-stripped, so that's nice. Got myself 4 pieces of insulation here. So what I'm going to do is I'm going to slide a long and then a short over each wire. And that should make sure that we never have breakthrough on these. Okay, capacitor replaced. The only thing I'm not sure about is the physical size here might be a problem. That is going to stick up farther. The question is, will it stick up through? It will. Okay, so now I just need a quick solution on what to do about that. So if I feed a second one down through here, I don't have to worry about it sliding down and eventually getting back out. So let's just put a little cable holder. Okay. Not quite as pretty, but it should be equally functional as before. So now I can kind of see the capacitor back here, but big deal. And now we try to answer the question, did I just waste $8? Maybe. I think it's spinning a little faster, but not a lot, so maybe this capacitor wasn't so bad off after all. I'm not sure if I have any good ways of testing it, but I can try and find out. I just remembered I have this little eBay 3-pin component tester here. If you haven't seen one of these, you can buy these. They just come as the bare board like this. You add a battery, but you can plug into any combination of the terminals labeled 1, 2, and 3, and it will attempt to detect what kind of component it is and what its value is. Don't mind these banana terminals. These are just here to hold the leads to the wire stubs from the capacitor, but let's press the button. Hey, look at that. Capacitor. 5866 nanofarads, so that's just under 0.6 microfarads. And I also like the fact that it actually tells you what the ESR is. You take 6 minus 0.6, which is, plus or minus 10%, I think is its rating here. Yeah, that's still a working capacitor. So whatever's going on with that fan, if anything, that wasn't our problem. Maybe the motor's just weak. But that's the way it goes sometimes if you take the shotgun approach. You replace a part, may solve the problem, may not. Move on to the next one until you figure out what it is. So anyway, that's an actual workshop quick take. See you again next time, whenever that is.
Has anyone seen my phone?